Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arifbut.me. You can click the appropriate link under the lecture resource column to view it in NB Viewer and run it online in Binder. Well, the other way is to download the notebook file from the course GitHub account Arif and all the notebook files are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally at port 8888. And here is the notebook for lecture number 3.23 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, today is our third session on data visualization, which is an important part of exploratory data analysis. If you have not watched the previous two videos on this session and are new to Matplotlib as well, I strongly recommend that you should watch those two videos first and then fall back to this one. You can find the link of all the videos of this course, Tools and Techniques for Data Science, in the description box below. Let me move on to the learning agenda of this notebook. In the very beginning, we will have a quick recap of some of the important topics that we have covered in the previous two videos. Anatomy of a figure, line, bar and scatter chart. And today we will learn the usage of pie chart and histogram. So let's have a quick recap, and first of all let's talk about anatomy of a figure. My dear students, this figure object marked by this red box is like a canvas. Everything that we want to draw will be on this canvas. Figure object can contain multiple axis object, and an axis object over here is marked in this blue box. This is where the data will appear. Right now this figure object contains only one axis object. However, this figure object can contain more than one axis, and this we have seen in our first session, I think. My dear students, every axis object normally has further two axis objects, an axis with an eye, the x-axis object and the y-axis object shown in green over here. The image on the right over here shows the collection of objects like the title of the graph, the legend, the grid, the major and the minor ticks along the x-axis label as well as along the y-axis label, the spines, the lines within the graph, markers in different colors, and so on. Well, after reviewing the anatomy of Matplotlib figure, let us quickly have a recap of the three types of charts that we have designed in the previous two sessions. And first of all, the line chart. We all know that a line chart or a line graph is a type of chart that displays information as a series of data points called markers, connected by straight line segments. A line chart is often used to visualize trends in data over interval of times. Well, this is a line chart that displays the amount of chemicals and medicines exported by a company LCI, Lahore Chemical Industries, in the last around 12 years from 2010 to 2021. From this legend over here, we can note that this blue colored solid line shows the chemical exports, while this red color dotted line shows the medicine exports. These points or markers on each line show the data points. For example, this marker over here shows the peak of the chemical exports, and you can note from this x-axis label over here that this peak occurred in the year 2016, and the amount of export in million US dollars can be noted from the y-axis, which is roughly a bit more than 0.94 million. So there is no doubt that a picture is worth 1,000 words. Let's move on to the bar chart. My dear students, after the line chart, we discussed and designed these two bar charts with vertical as well as horizontal bars. A bar chart is used when we want to compare a given numeric value on different categories to show a relationship between the numeric variables and the categoric variables. So these two bar graphs represent the marks of 6 students in 2 subjects. And from this legend, one can note that the blue bar represent the marks of a student in English, while this orange bar, they represent the marks of a student in math. In this vertical bar graph, we have the categorical variables, that is the names of the students, along the x-axis, while the numeric variables, that is the marks achieved, are along the y-axis. In this image over here, we have the horizontal bar graph representing the same data but having the marks of students along the x-axis and names of students along the y-axis. My dear students, this horizontal bar graph is preferred over this vertical bar graph if you want to represent the data of, let's suppose, 50 students. In such a scenario, the vertical bar graph will become cluttered because of lack of space, while this horizontal bar graph will simply grow downwards, and you will not face any issue in visualizing the bars of all the 50 students. Okay, I think enough of revision of bar chart. Let's move on to the third type of chart, that is the scatter chart. And we all know that these scatter charts are used when we want to show the relationship between 2 sets of values and see if they are correlated or not. My dear students, this is a scatter chart that we have designed in our previous session, and this represents the relationship between the price of 11 different houses with respect to their distance from location X and location Y. So the location X over here along the x-axis and Y over here along the y-axis. For each house we have 3 data values. The distance of the house from location X is along the x-axis, while the distance of the house from location Y is along the y-axis. Each of these markers represent a house. For example, this marker over here represents a house which is this one is 6 kilometers away from location Y and 2 kilometers away from location X. Well, other than these 2 data values, the third data value associated with each of these 11 houses is its price. And we have also added a color bar on the right of this scatter chart that maps the price of each house to a color. For example, you can note that the price of this house represented with a yellow marker is highest, around 900 million. This is being close to the location X and Y. And one more thing that this scatter plot shows is that the color and the sizes of these markers are not same for all the houses, rather are different for each house depending on the price. More is the price of the house, the larger is its corresponding size. And similarly, the color of every house is also dependent on this color palette shown over here. Okay, so far so good. We are done with a detailed recap of the types of charts that we have covered in our previous sessions. If you have not installed Matplotlib, please download Matplotlib and install it and import it. Okay, so let's talk about the pie chart first. My dear students, pie charts are similar to bar charts, but instead of plotting a bar for each category, a pie chart shows us the proportion to which each category contributes to the whole. For example, over here, we have a pie chart that shows the web browser market share, and it is apparent from this pie chart that Chrome is the mostly used browser, shown in yellow over here. From this figure, it is apparent that the pie chart is, of course, a circular graph that is broken down into segments called pies, and every segment represents each category's contribution to display parts of a whole. My dear friends, to create a pie chart, we use this pie method, having only one required argument, and that is this x, which is the list of numeric data we want to present for each segment or pie. And another important argument is this labels, which is a list of categorical values or the strings that we want to assign to each part. We'll talk about the remaining arguments to this pie method after having a basic hello world of the pie chart. Let us draw a basic pie chart first. Okay, my dear students, since today we have to cover many different types of plots, so I have already written some of the codes to save time. Let us walk through this code. First of all, we have this import lines. We need to import PyPlot module of Matplotlib. We can do this using any of these two import statements. Both are equivalent. You can use any one of them. This figure method of PLT will create and return a figure object, and this add underscore subplot method on this newly created figure object will return the axis object AX. Well, to plot a pie chart in Matplotlib, we use the pie method, and its only required argument is x, which should be the list of the data. Over here, I've just given two values to this data, name list slices 25 and 75, and we have passed this list to this x argument of the pie method, and then we have assigned it a title and called plt.show. Let me run the code inside this cell. Great. So you can see a circular chart having two slices, one slice covering around 25% of the circle and the other covering 75%. Well, the sum of the data values need not to be 100, as in this case over here, 25 and 75, 100. This need not to be the same. Let me change this. Let me change this to, let's suppose, 50, and let me change this to, let's suppose, 150, and let me run it again. You see the same chart? The pie chart will calculate their percentages accordingly, implicitly. Great. So no change in the proportion of the two pies once we have changed this. Let me add a third value. Let me say the third value to be, let's suppose, 300. Just a random value. Let me run it again. Great. Now we have three slices, and we have this slice covering 50%, rather the value 50 correspond to this blue pie, the value 150 correspond to this orange pie, and the value 300, the maximum, correspond to this green pie. But still I do not know what these three slices actually mean. So let us add some labels to make these slices understandable. For that, let me create a list, labels, and let me assign some strings to this. Let me say 1 and 2, and let me say 3, and let me pass this list labels to the second argument of the pie method, labels. Great. Let me run it again. Okay, so now we have some meaningful names that have been associated with each of the pie. Let's move to another example, a meaningful example. Okay, so over here I just want to design a pie chart that shows the student counts in the Faculty of Computing and IT at the University of the Punjab. Now the data for the pie plot is the student count. The student count list contains the count of students in the 4 departments, and the department list contains strings having the names of the 4 departments. So we have 130 students in the data science department. 550 students in the computer science department, 250 in the software engineering, and 400 in the IT department. These are just hypothetical values. And over here I have called the pi method, and I have passed it the student count as well as the labels, and we have the title. And let me run this code. Great. So you see the pie chart has automatically calculated the proportions or the percentages of these values or student counts. That is why we have this CS department having 550 students. So this is the largest pie. And this data science department shown in blue over here has having 130 students is the smallest sized pie. Great. Okay, now let's suppose that we want to show the percentages of each data value inside the pie. This can be done by passing an appropriate format string to an argument to this pie method, and that argument is AutoPCT. So let me show you the help page. My dear friends, please do go through this help page and see the different arguments that you can pass to this pie method. And for the time being, let me pass this AutoPCT argument and let me give it a string, and that string says that I just want to show, let's suppose after the decimal I just want to show 1 decimal point, and let me show this percentage. Please do go through the help pages on the Jupyter notebook, or you may go through with the documents of the Matplotlib to find out the different formats that you can pass to this AutoPCT argument. So let me run it. Great. You see we have now appropriate percentages: 41.4% CS, 9.8% data science. So these are the appropriate percentages of student counts inside the pie of each department. My dear friends, we can always customize the color of each pie by passing a list of colors to the color parameter of this pie method. And for that, let me just copy this over here. So blue, red, yellow, green, 1, 2, 3, 4. We have 4 colors, and let me pass this list of colors to the colors argument of the pie method. These are very bright colors. My dear friends, you can use these bright colors if you want to, but I have used certain colors of my choice, some RGB palette values. This is R, G, and B, 6 hexadecimal digits showing the intensities for the red, green, and blue colors for the composition of these colors. Let me pass this. Okay, so this is now a bit more professional as compared to the previous colors which were too bright for the eyes. Anyway, my dear friends, at times we want to focus on a specific category, such as the one with the highest or the lowest value. We can use another argument to pi for this purpose, and that is the explode parameter. The explode parameter of pi method is used to emphasize any number of these wedges or pies within this pie chart. So the explode parameter will be a list of values. So let us do that as well over here. Let me just create a list. Explode is equal to, let me say, 0.2, 0, 0. So this list contains 4 values. This value corresponds to this data science, and this 3 zeros corresponding to CS, SE, and IT. So by using this 0.2 for this label DS or this segment of the pi DS, we just want to take this slice a little bit out from this. Let me run this and then I will describe it. Okay, so I have not passed it over here. Let me pass this argument as well. Explode is equal to explode list. So great. So this is what explosion is in case of a pie chart. You can note that this slice has been pushed out a little bit. Let me make it 0.5 and let me run it. You see, now this is almost half of the radius out of this. This doesn't look good. Let me make it 0.1. So this is fine. This is fine to me. Well, my dear, there are other than this, there are other arguments as well. Let me use the shadow argument as well, and let me pass the shadow argument, and let me make it true. By default, it is false. By making the shadow argument to true, you can see it gives a 3D impact. One more argument is that if we want this pi of ds to be at some different place over here, let's suppose that we want this ds should be here, so we want to rotate this pi, so you can use the argument start angle, and let me give it 190 and run it, and you see this is over here. Let me make it 0.2. Great. So we have a good looking pie chart that shows the count of different students, not the count exactly, rather the proportion of different students in the 4 different departments of Faculty of Computing and Information Technology at PUCIT. Great. Okay, so let me move ahead and let's talk about another example. So in a previous session, my dear students, we have seen this dataset. That is the Stack Overflow Annual Developer Survey dataset. We have just read this CSV file containing the data of this dataset into Pandas data frame using the read_CSV method. And I have just shown the first 5 records of this. Okay, so what we want to do in this example is we want to draw, I think we have drawn a bar graph showing the popularity of different programming languages in a previous session based on this column over here. And this column, as you can see, contains semicolon separated programming languages names given by respondents who filled this survey form. And I think in the last session, we programmatically gathered the list of the unique programming languages as well as their corresponding counts. Okay, so we have done this before as well. Okay, so this time I just want to draw another graph for this. Okay, so here it is. We have the list of languages that we have gathered over here, and we have the popularity count. So using this list of languages and the number of people who said that they have been using this language from this data frame, in the previous session we have created a bar graph. Let's draw a pie chart for this. So I have called the pie method and I have passed it the popularity, that is the count, and the labels is the languages. And let me just draw this pie chart and show you the pie for the popularity of programming languages. My dear students, if you have seen the previous session, that was the one in which we used this data to draw a bar graph, and that represented a better visualization as compared to this pie chart. So my dear students, a pie chart really doesn't look good if there is too much of the data. The information gets cluttered, and better to use the horizontal bar chart for such data as we have done in the previous session. And please restrict yourself to the use of pie chart if you have just 5 or 6 categories. Okay, I think enough for the pie chart. Let's move on to the next type of charts, that are the histograms. Great. My dear students, histogram is an important graph used in statistics and data analysis, and is used to quickly understand the distribution of data. Since a histogram also has bars, so one normally gets confused between a bar chart and a histogram. So before proceeding, let me give you a quick comparison between a bar chart shown on the left and a histogram shown on the right. My dear students, the main difference is uh, a bar graph uses bars to compare different categories of data, while a histogram uses bars, once again, to display the frequency of this numerical data. Moreover, a histogram is used for displaying the frequency of occurrences, while a bar plot is used to compare different categories of data. In a bar graph, each of the data point is rendered as a separate bar, and the bars never touch each other. While in histogram, uh, the data points are grouped and rendered based on its bin values, and mostly the bars of a histogram touch each other, having no space in between the bars. So to summarize, let me say that a histogram takes a list of numeric dataset. It creates appropriate number of bins that should cover the entire range of data. For example, over here you can see there are bins over here. Then it places the data values into the corresponding bins, count how many values fall into each of the different bin, and then draw a bar for each bin, where the height of the bar represents the data points that reside in that bin. Well, these points are mentioned over here. This is just a theory. To draw a histogram, we use this hist method, having only one required argument, which is x, and x is actually the list of numeric data whose distribution we want to understand. Another important argument to the hist method is the bins argument over here, which can take a scalar integer value representing the number of bins, which will be the equal width bins in the data range. And the bins argument can also be passed a sequence, in which case bins may be unequally spaced. I think enough of theory. Let's jump into the code to understand all these points which I have just uttered. Okay, let's once again read the Stack Overflow dataset into a data frame using the read CSV method. So this is the data frame. Okay. So over here, this column, age, this shows the ages of all the respondents who filled this survey form. Let us suppose that we want to find out what are the different age groups who participated in this survey. In other words, we want to find out how the data under this age column is distributed. And of course, histogram is the best chart for this purpose. Okay, so let's see the info about this data frame by calling the info method on this data frame. So there are over 88,000 entries or rows in this data frame. And if I talk about the age column, there are 79,210 non-null values. So there are NaN values under this age column. You can see the NaN values over here. So let me drop the NaN values. Let's use the drop NA method. We have used it before as well. Let me use this drop NA method and pass it the argument subset is equal to age, because I'm just interested to drop the rows in which there is a NaN value under the age column, and I've mentioned the in place argument to true, so that the changes should be made inside the data frame. And after I have done that, I have called again the info method on data frame. And now if you see that we have total rows of 79,210, and which are the same as the known null values under the age column. So previously, this data frame has 88,883 entries, and now it has 79,210 entries, and there is no NaN value under this age. Let me show this to you again. Let me show the data frame. You can see there is no NaN values under this age column. So we have done the first task. Let me now show you the list of the ages under this data frame column, and let me receive the list in ages underscore list. So this is the list starting from the age 14, 19, 28, 22 and so on. So there are 79,210 different ages we have over here. Great. So let us plot a histogram on these values. So these are the two lines. As usual, create the figure and the axis object. And this is once again the ages underscore list containing all the ages under the age column of the data frame. And over here I am using the histogram method and passing it the x argument, the list of ages, and we are setting the title of the graph over here, setting the x label, the y label, setting the grid to true, and finally we are showing the plot. Let us run the code of this cell. Oops. So we have ages is not defined. So ages underscore list. We have ages underscore list. So why it is not working? Let me run it again. Ages underscore list. Okay, so ages underscore list. Let me run it again. Great. So this is the histogram. Along the x-axis we have the ages, and along the y-axis we have the count of respondents. And you see matplotlib has automatically divided the entire dataset into 10 equal size bins. First bin is from 0 inclusive to 10 not inclusive. Second bin is from 10 inclusive to 20 not inclusive. The third bin is from 20 inclusive to 30 not inclusive, and so on. And from this histogram, it is apparent that almost more than 40,000 plus of the respondents belong to the age group from 20 to 30, and around 2,500 belong to the age group between 50 and 60. So this is the bin for 50 and 60. Great. Okay, so this was with the default size of the bins. Let me create bins of my choice by passing a list to the bins argument of this hist method. Let me create a bins list. Let me say bins is equal to, let me say 10, 20, 30, 40, 50, 60. Okay, let me put 100 as well. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. These are the bins. So the first bin will start from 10 inclusive to 20 not inclusive. The second bin will start from 20 inclusive to 30 not inclusive, and so on. And over here, let me pass this to this bins. Bins is equal to bins. Great. So let me run it. Great. So you see we have these bins, appropriate bins. Let me pass another argument to this, the edge color. Let me set it to black. And once we pass this edge color black, you can see this line over here, which is differentiating between the two bars of the histogram, which are just attached with each other. And let me change the color of these bars as well. And let me make them, let's put green. The default color is blue. You can set them to any color of your choice. Okay, so the color of the bars have gone green. Great. And we have these black lines as well over here. Fine. From this height of these bars, we can observe that in this first bin from 0 to 10, we have this data. 0 to 10, we don't have any data for 0 to 10, although we do have data for 10 to 20, that is 5,000. There is small amount of data between 70 and 80 in this bin. And from 80 to 90 and 90 to 100, it appears that we do not have any data in these two bins again. Okay, My dear students, remember there can always be a possibility that as compared to this count that is around 40,000, mm, and these values, uh, there may be a age group which has very lesser number of respondents that falls in this age group, maybe very lesser number of respondents, and that can be the reason that you do not see a bar over here. So if you have some values that are a lot more than other values, you can plot the histogram on a logarithmic scale. So let me do that. And to do that, you just need to pass an argument to this hist method, and that says log is equal to true. Let me run it. Great. Now this histogram is plotted on a logarithmic scale. Observe that we do have the data for the bin between 80 and 90 and 90 and 100 as well. We actually have more people who responded to this survey in the age group of 90 to 100 as compared to the age group of 80 to 90. So far so good. Okay, so let's move ahead. Let's enhance this graph a little bit. And to enhance this graph, let me copy paste this from here, and let me paste this code over here. And let me add some additional information to this histogram. And suppose I just want that I just want to add some additional information. Suppose that I want to add two vertical lines showing the mean and the median age in this histogram. And we all know that the mean is the average and the mode is the most common number in our data set. So let me see that if that we do have the code over here. So let me use this code. I'm just calling the median method on this series of the data frame to get the median of the median age. df1 is not defined. Okay, let me make it df. Yes, let me make this df as well. So we have the median value of the age column, and we have the mean value as well of the age column. I just want to add these information to this graph in such a way that it should be represented by a vertical line. And to do that, I have written the code for you. Let me just discuss the changes over here. So these two lines which I have just highlighted, they are just calculating the median and the average age, and these two lines are actually drawing the vertical lines. Well, this AXV line method probably stands for axis vertical line. This is past the median age that we have just calculated, the color of the line we want to draw, and we have assigned it a label as well, that is median age, and this label will probably be used by this legend method as well. So we have called AXV line twice, once for the median age and the next for the average age, and then we have called this legend as well. Let me just run this code and show you the difference. Okay, so once again we have used df1 over here. Sorry for these typos. Okay, so great. So my dear students, you can note these two vertical lines over here. The red line showing the median of the age that falls somewhere over here, and the black line showing the average age. And you can see the legend over here, appropriate legend, that has been shown over here because of these two labels that we have mentioned inside the AXVL line. Anyway, I have also saved this histogram using the savefig method. Great. Let me move ahead and see what else we need to do today. Okay, so we need to talk about the histogram of an image now. So let me show you an image. Let me use the open method of the image module of the PIL package to read this file arif1 underscore color.jpg. So this is a a color file, RGB file, an image file that I have read inside this handle. And over here I'm just calling the convert method and passing it L. Just go through the help page of convert method. I think we have discussed this in our file handling session as well as in our last session of NumPy module where we have done with the IO. Let me run it. It will just convert this RGB image to a grayscale image. Let me show this image to you. So this is a grayscale converted image. Remember, my dear students, this grayscale image is converted using this formula. So these are the R, G and B values that are multiplied by these corresponding values to get the grayscale intensity of this image. I think this makes sense. Okay, so after we have got the grayscale image, I am calling the array method, passing it to the array method and converted it to a 2D NumPy array. So this is a 2D NumPy array representing this grayscale image, and these values are actually the pixel intensities of this grayscale image. And remember, a value of 0 means black and a value of 255 means white. And the shape of this is of course 300 by 250. So let us draw a histogram of this grayscale image to indicate the number of times each gray level occurs in this image. And this is the code once again. Note that over here we have just created the figure and the axis object. I have created the bins. I've created 5 bins from 0 to 50, then from 50 to 100, 100 to 150, and so on to 255. Over here I am calling the hist method and pass the 2D array containing the pixel intensities and of course the list of bins as well. And then we have the title, X label and grid and so on. Let me run the code of this cell. My dear students, remember, okay, great. Remember this image histogram does not tell you what the image actually contains. That is, by seeing this histogram, you cannot say that this is the image of a face or whether this image is of an aerial view of a city or whatever. However, this image histogram do give you the global appearance of the image. That is, the image appears to be on the darker side or on the brighter side. So if you closely see this image over here, along the x-axis we have the gray levels, the intensity levels starting from 0 to 255, and over here we have the pixel frequencies. So this histogram shows that the majority of the pixel intensities fall in the bin having intensities 100 to 150, and the majority of the remaining are once again on the upper side over here. So overall this image appears to be on the brighter side. Great. Once again, my dear students, today's session has gone a bit longer than my expectations. I have tried my best to make you understand the nitty-gritties of the pie chart and histogram by giving a lot of examples. And I am hopeful that you will be able to apply this knowledge whenever the need arises in the later part of the course and during your research work and while doing some practical job in the industry. Okay, so that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. And I hope today's session was informative for you all. If you have liked it, please do subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.